I will now describe an encoder-decoder architecture and how that can be used for neural machine translation. Let's assume that we want to translate Arabic sentence into an English sentence. We can view this as a text auto-completion problem. We simply concatenate the Arabic sentence with the English sentence, and then we train a language model. We provide the Arabic sentence to the model and ask it to do auto-completion. This is how we can do a neural machine translation by simply using a neural language model. This figure shows an illustration of how you can use a language model for neural machine translation. We have a network with an embedding layer, as you can see here, and then a hidden layer, recurrent layers, and then a softmax layer, and we would use auto-regression to predict a sequence of arbitrary length. So let's look at unrolled in time. As input, we provide an Arabic sentence to the network. That is followed by a special character token start. This signals to the network that it is time to start producing a translation. We then train to output that same sentence but in English, as you can see here, followed by a stop token. This will signal to the user that the full translation has been produced. When using the network, we will do auto-regression. That is, we will feed each word back to the network, and we do the same thing during training. So we provide the answer as input, but one step delayed, so the network can't cheat, as you can see here. So we see that when we have the start token, the network will produce I as an output. Just looking at the training example, we see that the input in the sentence in Arabic followed by the start token. Then the English translation, and the output is just the English translation plus the stop token. But the English translation is shifted, so it is one step earlier in time, as you can see here. One thing stick out when we are looking at this model, we consume a sentence in Arabic and then we generate a sentence in English. In some sense, these are two different tasks and they are working with two different languages. Therefore, we can take an alternative approach. Instead of using a single network, we can use two separate networks. We have an encoder network, as you can see here. This is the encoder. And we have the decoder. The encoder network will encode the Arabic sentence into an internal representation. This internal representation captures the overall meaning of the sentence. Then we use the decoder to decode this internal representation into a description in English. This decoder is simply a neural language model, but it's conditioned on an initial state. This initial state is produced by the encoder, and the initial state is simply the internal state of the recurrent layer. Or in the case when we use LSTM, it's both the C state and the internal state of the LSTM cell, as well as the hidden layer, the hidden state. So C and H. It's also worth noting that we are working with two separate embedding layers. The encoder has an embedding layer that embeds Arabic words. The embedding layer in the decoder works with an English vocabulary.